Hello, my fabulous chemistry faithful. Video number 4, drawing ionic compounds. We're going to use this ABCD method so you can figure out how to draw ionics, the first of the real tasks of putting everything together. So this is what it stands for. ABCD means I need atoms, brackets, charges, dots. You use that as your checklist, you get all those things, and we are set. So watch this one time before you draw it. I think I have it all animated beautifully. Ready? So LiCl, no numbers, one of each. The fact that I wrote Li means there's one. I don't need to put a number 1 in the subscript, so I write my atoms. So there's my atoms, Li and a Cl. Those are my atoms. And I need brackets. So I put brackets around everybody. It's most important they put the brackets around the non-metal for sure, because we'll find that the metals lose their valence electron to the non-metal. The brackets mean my electrons, you cannot have them. So because there's a complete transfer of electrons in ionic bonding, we draw brackets, okay? And then I put in my charges, +1, -1, and of course, the reason why, and I only did that to go in order, I put the dots in first because, right, that's how I get it. So there we go. So I have atoms, brackets, charges, dots. Lithium by itself has 1 dot. Chlorine has 7 dots, and I used it in red just so you guys can see that the red dot is the one that came from lithium. When lithium loses an electron, he becomes a +1 ion. When chlorine gains an electron, he becomes a -1 ion. Plus and minus, whoop, stick together. So this is the correct way to draw lithium chloride, okay? And I know I need one of each because there is those charges, +1, -1 equals 0. So again, atoms, I see 1 calcium because there's only 1 there. And then the 2 is to the fluorine, so there's 2 of them, okay? And then I'm going to put in my brackets, atoms, brackets, right? Charges, dots. So I'm just going to go in order with that. Like I said, I normally put the dots in first. Calcium forms a +2 ion. I see that on the periodic table. The first negative for fluorine is -1. Oh, and fluorine only has the -1, which is good. And we'll notice, again, nonmetals you're going to find have all 8 electrons. All metals have no electrons in ionic bonding Lewis structures. Ionic bonding Lewis dot structures. Lewis structures, dot structures. It all means the same thing, okay? And that's what we're drawing. Atoms, brackets, charges, dots, okay? We notice that group 1 metals form +1 ions. So here's a bunch of them. Na, C or K, Li. Group 2 metals form all +2 ions. So beryllium, magnesium, probably calcium next, right? There we go. They all form +2 ions. So that's always going to be the case. My nonmetals in group 16 always form -2. So oxygen needs 2 electrons. Sulfur needs 2 electrons. Ceruleum needs 2 electrons. All those came out a little funny, but they're there. Okay, but they're animated, so sorry they came out weird. The nonmetals in group 17 only need 1 electron, so they form -1 charges. And this is why they get those charges. And this is how you're going to draw them every time you see them in a particular example. Okay, so I know I went fast, but you're going to have to get those in there. Transition metals form multiple ions. So here's fun. I can have copper +1. I can have copper +2. Okay. Iron +2 or iron +3. Those I have to look up, and I'm going to teach you in class how to use the charge cancellation to make sure. PO4, polyatomic ion, the charge is right there, so it's a -3. The 4 is telling me there's 4 oxygens. There's a -3 charge for the whole thing, so it's scooped up 3 electrons along the way. There's polyatomic SO4, which is sulfate. These are listed right on table E. Okay, CO3 carbonate, got a -2. And now I have to draw some for you. I have to draw a bunch. Okay, so BA is a +2. I is a -1, so there should actually be another I right here because there's 2 of them. So I'm going to say BA +2 brackets. It's a metal. Iodine. 1, 2, 3, 4, 5, 6, 7.
iodine. 1, 2, 3, 4, 5, 6, 7. I'm going to draw it like this in red, just so you can see where he got his electron from. He's a -1 now. He's a -1 now. Formula is BaI2. Takes two -1s to cancel out with a +2. I'm going to move right along. These guys are 1 and 1. So this is easy. I got K with a +1. I have iodine. 1, 2, 3, 4, 5, 6, 7 is what he normally had. He gets 1 from K. And he gets his brackets and his -1 charge. And this is just Ki. This is exactly what the practice looks like for you, so you can be able to do it. And yes, I'm going fast because I don't want any more 24-minute long videos. Here, I only listed these both once because a +2 and a -2 cancel out. So that's good. I'm good there. So Ca is going to be a +2. Oxygen comes with 6 valence electrons. It's going to look like that. He's going to get 1 from Ca that goes there and 1 that goes there. He's going to have a -2 charge, and he's just going to be CaO. Now here, I have a +1 and a -2. I need 2 +1s to cancel out with 1 -2. So I'm going to have O in the middle. 1, 2, 3, 4, 5, 6 is how he comes. All by himself, he comes to the party like that. Cs comes in and loses his electron, forms a +1 ion, and that electron goes there. And then another Cs forms a +1 ion, loses his electron, that goes there, which makes him a -2. So this is Cs, 2 of them, with an oxygen. Moving right along, last one, Na +1. Sorry, my pluses is a little bit rusty. So my S in the middle is going to come with 6. I looked that up. I have 6 valence electrons. Na is going to lose 1. Bow. It goes there. This Na is going to lose 1. It goes there. He now has a -2 charge. +1 and +1 is a +2 with a -2 goes to 0. So I'm electronically neutral. There we go. Na2S is what I count up. So with that, that should be all of it. We done. We just learned how to draw ionics. Please, please practice. Please, please check your work. See you in class.